It's your friendly math tutor, Miss C here, and today we are making a table of values for this equation, y equals 4 to the power of x minus 3. Hopefully right away you're going to note that this is an exponential equation. What that means is our graph is a curve, and we are going to need, as always, when we make a table of values, to use negative values and positive values to sketch it most accurately. So I'm going to go ahead and set up my t-table. I've got x on one side, y on the other. What we're essentially doing when we make a table of values is we are creating sets of data points. When we plug something in for x, we're figuring out what y equals. So I always like to include 0 because that's always a nice value to plot. We know that this exponential function is going to be some sort of curve, like we're not sure how steep it is or how not steep it is. So I'm going to actually put on a few more values than I would normally put on, and I'm going to space them out a little bit because I really want to get the feel for how this graph is going to look. So I probably should just do this because I don't know why I skipped one number and not the other. So I'm actually going to pull out 7 values so we get a solid look at how this curve is progressing. So I'm always like to start with my 0 value because I feel like that's easiest. So we're basically going to be plugging in values here to find our solution to find our y value for every x value. So it's going to require knowledge of exponents. 4 to the 0 power is 1. 1 minus 3 is negative 2. So we know that we have a y-intercept of negative 2. So I'm just going to note that that's our y-intercept. So that's where it crosses the y-axis. And then I'm going to do my positive values first because negative exponents give me fractions. And not everyone is so excited about fractions as I am. So I'm just going to go ahead and do this. I'm plugging 1 in for x. 4 to the 1 is 4 minus 3 is 1. Okay. Now, before you start saying, oh, well, that was an increase of 3, I'm going to keep increasing by 3. Can't do that. This isn't linear. So what we're going to notice is when I replace my exponent with a 2, I end up 4 squared is 16 minus 3 is 13. Okay, so definitely not linear at this point. And I'm going to do the same thing. I'm going to replace this 2 with a 3. 4 cubed. So 4 times 4 is 16, times 4 is 64, minus 3 is 61. All right, so this grew really fast. I started with negative 2 at an x value of 0, and by the time x is there, I'm already up to 61. So pretty steep incline. And now let's do the negatives. So I'm going to come over here. Just do a quick review of negative values. So 4 to the negative 1 power is really 1 over 4 minus 3. So this is 2.75, or if you wanted to, you could get a common denominator of 4, and it's negative 2.75. Okay, I'm going to do the same thing. Oops, let me grab my eraser. So I'm going to, this becomes negative 2. This becomes 1 over 16, right? Negative exponents basically make your number smaller. Like you change the location of your base and the exponent turns positive. So 1/16 minus 3. This is kind of a yucky number, so we could leave it. I think I'm going to leave it as a fraction. So this is going to be negative 2 and 15/16, right? Okay, you could put this in your calculator and get the answer out. And then we'll do this one more time with negative 3. Okay, and then we end up with negative 2 and over 63 over 64. So those are pretty gross numbers, but what we're noticing is they're not getting that much smaller. So if I were to go ahead and put this in my calculator, what I'm going to find is that 1/64 minus 3 is like negative 2.98 about. And 1/16 minus 3 is not that much bigger. So we're like getting very, very close to -3, which is this number right here, but we're never actually going to quite get there. So if I were to sketch this graph, right, what I know is that my y-axis is a little crooked. So if this is -3, what I know is my graph is going to do something like this, okay? It's never going to touch -3, but it's going to get super duper close. So that's called an asymptote. And that's fundamentally how exponential functions work. They approach an asymptote but never touch it, and then they get really big or really small on the other side, depending on if it's reflected or not. So there you go. That is how you make a table of values for an exponential function.